A tornado is one of nature's most violent spectacles. A spinning column of air that stretches from the storm clouds right down to the ground, with winds strong enough to fling cars through the air and flatten a house in seconds. But where does all that ferocious spin actually come from? The answer is a beautiful and slightly terrifying chain of events. So let's build a tornado, step by step. It all begins with a giant thunderstorm. And to grow one, you need two ingredients stacked on top of each other. Down low sits warm, moist air near the ground, and high above it much colder, drier air. Warm air is light, so it desperately wants to rise, punching upward through the cold air above in a powerful updraft. This towering storm becomes the engine that powers everything that follows. Now for the spin. High in the sky, the wind doesn't blow the same everywhere. Near the ground it might be gentle, but higher up it races along much faster and often from a different direction entirely. This change in wind with height is called wind shear, and it does something clever. It sets a tube of air rolling like an invisible barrel tumbling sideways through the sky. Here's the crucial moment. That powerful updraft from our thunderstorm slams into the rolling tube of air and tilts it upright. But at first, this only gives us a broad, slow-spinning mass of air, often miles wide. So why does it cinch down into a narrow funnel instead of staying a great big rotating blob? The secret is stretching. The storm's updraft keeps hauling that spinning column upward, stretching it taller and taller. And a spinning column that's stretched tall has no choice but to pull inwards and grow thin, just like a lump of clay on a potter's wheel narrows as you draw it upward. As it's stretched and squeezed, that wide rotation tightens into a slender funnel, snaking down and down, until it finally touches the ground. That is a tornado. But why does a thin funnel spin so unbelievably fast? Think of an ice skater. When she spins with her arms stretched out wide, she turns slowly. But the instant she pulls her arms in tight, she whirls faster and faster. Tornadoes obey the very same law. As that wide column of air is squeezed into a narrow funnel, all of its spin concentrates into a tiny space, and the winds scream up to terrifying speeds. So a tornado needs a very particular battleground, a place where warm, moist air and cold, dry air can violently crash together, with strong wind shear overhead. In the United States, the flat central plains are perfect for it, earning the nickname Tornado Alley. It's here that cold air sweeping down from the north collides with warm air drifting up from the Gulf, spawning more tornadoes than anywhere else on Earth. But not every tornado is equally destructive. To measure their strength, scientists use the enhanced Fujita scale, which rates a tornado from EF0 to EF5, based on the damage it leaves behind. An EF0 is the weakest, with winds around 65 miles an hour, just enough to snap branches and peel a few roof tiles. But at the very top sits the monstrous EF5, with winds screaming past 200 miles an hour, strong enough to rip a well-built house clean off its foundations, and fling cars through the air like toys. So a tornado is really just a recipe. Start with warm air trapped beneath cold air to build a towering storm. Add wind shear to set the air rolling. Let the storm's updraft tilt that spin upright, then stretch it into a tight, screaming funnel. It's a rare and violent alignment of forces. But when they all line up, the result is the most intense wind on the entire planet. That's how tornadoes form. I'm Mr. Sticklab. Stay curious, stay safe, and I'll catch you in the next one.